By properly inspecting the tires and wheel ends during every pre-trip inspection, drivers can comply with federal regulation and make the highways safer for themselves and other motorists. A wheel off or wheel end fire can occur when any component on a wheel end is poorly maintained. Wheel bearings, lug fasteners, studs, and brake components must be regularly inspected and included in a preventive maintenance program. When properly maintained, wheel ends can last for the life of the vehicle, but when they are neglected, wheel end failure is unpredictable with catastrophic results.
To properly inspect a wheel end, the first step is to park the vehicle on a level surface, block the wheels, and lift the axle. Release the jack and secure the axle with jack stands of sufficient load carrying capacity. With the brakes released, rotate the wheel and check for free, smooth, and quiet rotation. Next, remove the fasteners and the wheels. For most Class 8 trucks and trailers, there are currently 3 types of hub wheel bearing systems available: manually adjusted bearings, pre-adjusted bearings, which are often marketed under the name preset or LMS, and unitized bearings. In order to properly service and install the various types of wheel ends, it is important to identify the bearing system on the vehicle and to follow the service recommendations for that particular wheel end system. Hubs with manually adjusted bearings should be installed per TMC RP 618. Hubs with pre-adjusted bearings and unitized hubs have product-specific service and installation procedures. On standard manually adjusted bearings, remove the hubcap or the drive axle. Use a dial indicator to measure the wheel bearing end play. If the end play is above the hub manufacturer's recommended maximum tolerance, service the wheel end per the hub manufacturer's recommendations. If the end play is within specifications, reinstall the hubcap or drive axle and then install the proper lubricant. On outboard assemblies, remove the brake drum and carefully inspect it for any cracks or damage. It is also important to inspect the wear indicators to ensure there is sufficient brake lining. Before reinstalling the brake drum, inspect the hub and make sure the pilot pads on the hub and the mating surfaces between the brake drum and the hub are clean and free of any rust, dirt, paint, or corrosion. The best practice is to use a wire brush to clean all of the mating surfaces and remove any traces of foreign material. Failure to adequately remove all of the debris will permit the corrosion to continue. All abrasive residues should be removed with a clean shop towel.
Do not use acid or other highly corrosive material to clean the hub polish or mating surfaces. These materials promote further corrosion if they are not completely removed.
Before reinstalling the drum, make sure the mating surfaces are cleaned with a wire brush. Pay particular attention to the edge of the center hole where the drum contacts the hub. Remove all foreign material with a clean shop towel. Once all of the components have been properly inspected and cleaned, apply a light coating of corrosion inhibitor to the pilot pads, and then position a pilot pad at the 12 o'clock position so the brake drum can be centered on the hub. With the pad properly positioned, get the help of another technician or use the appropriate brake drum dolly to install the brake drum. All of the mating surfaces on the wheels must be cleaned with a wire brush and inspected before they can be installed on the vehicle. If any damage or cracks are visible, the wheel must be removed from service and scrapped immediately. Welding on a rim or wheel will change the properties and strength of the metal. Never apply heat or weld on a wheel, especially when the tire is still mounted on the rim. The temperature of a welder can reach 11,000 degrees Fahrenheit or 6,000 degrees Celsius on contact. While as much as 50% of the heat is lost through conduction, the surrounding metal is still heated to extremely high temperatures, which ultimately heats the air inside the tire. When the rubber inside the tire reacts to the heat, it generates gases that can lead to an internal fire. Eventually, the rising heat and pressure becomes too great for the tire and rim to contain. While internal changes will not be apparent to the outside observer, the severe increase in temperature and pressure will cause the tire and wheel to catastrophically explode without warning.
Remember, it is an OSHA violation to apply heat or weld on a wheel or rim. When you weld on a wheel or rim, you're placing yourself and others around you in imminent danger, especially if the tire is still mounted. If a repaired wheel or rim fails, experts will agree that it should have never been repaired in the first place.